In this video, I will explain AC inverting amplifier. AC inverting amplifier configuration. Okay. AC inverting amplifier using op-amp. This is the circuit diagram. Minus plus 741 in inverting amplifier configuration. R1, RF, is V0. RL V0 is equal to minus RF by R1 into V. Coupling capacitor here, we use coupling capacitor CE plus minus V. RE is equal to R0. R0. This one is minus V plus VCC. 10 kilo ohm resistance part. The wiper terminal of that resistance is connected to minus VE. This is the wiper terminal. These are the offset terminals. This one is pipe. These are the offset terminals. This one is offset. Offset terminal of the top end. Offset terminal. Offset terminal of the top. 741 IC. This one is 741 IC. We use the coupling capacitor. Coupling capacitor play an important role here. Generally, if the designer needs AC response, the designer needs the AC response characteristics. AC response characteristics of the op-amp. That is low and high frequency limits. That is low and high frequency limits. Frequency limits. FL and FH. It is necessary to use an amplifier with a coupling capacitor. An amplifier with a coupling capacitor. Coupling capacitor C. Coupling capacitor C. This is the coupling capacitor C. If the designer needs AC response characteristics of the op-amp, that is low and high frequency limits, FL and FH, it is necessary to use an amplifier with a coupling capacitor CA. Second point is, suppose in an audio receiver system that consists of number of stages, because of thermal strip component in an audio receiver, system that consists of number of stages. Because of thermal drift. Because of thermal drift, component tolerances and variations. Component tolerances and variations. The DC level is produced. To prevent the amplification of such DC levels, we use some coupling capacitors. To prevent the amplification. To prevent the amplification of such DC level, coupling capacitors. Capacitors must be used between the stages. The coupling capacitor not only plots the DC voltage, but also set the low frequency cutoff frequency. The coupling capacitors not only blocks the DC voltages, but also sets the low frequency cutoff, which is given by FL is equal to 1 by 2 pi Ci RIF plus RIF. This is the cutoff frequency where FL is the lower cutoff frequency. Low frequency cutoff. Low frequency cutoff or low end of band. CA is the capacitance between two stages being coupled. Or DC blocking capacitor. RIF, AC input resistance of the second stage. In that expression, RIF is there, R not is there. RIF is the AC input resistance of the second stage. R not AC output resistance of the first stage. AC output resistance of the first stage or the source resistance. are the source resistance. This is the inverting of an AC amplifier. Here Vin and Rn is equal to R0. That is very low value. Is coupled to the input terminal of the op-amp through coupling capacitor CL. Here we use RF is also very important. This ROM is used here to prevent the biasing current effect. And here some 10 kilo potentiometer and connected between two offset pins of the op-amp. And the wiper terminal of the potentiometer is connected to a negative power supply of the op-amp to prevent the offset voltage at the out. By using these two, ROM is the resistance which is connected at the non-inverting terminal of the op-amp to prevent the bias current effect. And this 10 kilo ohms potentiometer is connected between two offset terminal of the op-amp, and wiper of that potentiometer is connected to negative power supply of the op-amp, prevent the offset voltage effect at the out. By using these two are very important. Coupling capacitor here CA is used to couple the input signal to the inverting terminal of the op-amp. CA is playing important role to plot the DC signals, allows the AC signals, set the lower cutoff frequency of that frequency response of the op-amp. Sometimes we need some AC characteristics of the op-amp. AC characteristics means bandwidth, lower cutoff frequency, higher cutoff frequency. But op-amp is a high gain direct coupled amplifier. In some cases, we need a CA coupling capacitor also needed. CA. Here some block diagram. This is the V in, R in, R0. This is coupling capacitor CA. RIF is approximately equal to R1. This is the VA. VA is the voltage applied to the inverting terminal of the op-amp. This one is inverting terminal of the op-amp. Here V in, Rn is equal to R0, coupling capacitor CA. RIF is approximately equal to R1. Some RIF is also there from this point to this point. According to Miller's theorem, this input side RF by 1 plus A. Here A is very high. That is RF by A is infinity. That value is 0. Low value. A is a high value. RF by A is the low value. That is approximately equal to R. That is approximately equal to R1. RIF is equal to R1 plus input resistance Ri. Input resistance Ri of that op-amp is parallel with RF by 1%. This value is approximately equal to 0. This value is approximately equal to 0. Therefore, RIF is equal to R. RIF is equal to R1. This is RIF is equal to R1. Find out VA. VA is equal to, according to voltage gain rule, total voltage applied to the circuit is VE. That resistance is RIF by sum of these three. R0 plus RIF plus 1 by J omega CA. This is reactance of the capacitance is 1 by J omega CA. Therefore, VA is equal to J omega CA RIF V is equal to J by J omega Ci R naught plus RIF into J omega Ci plus 1 by J omega Ci. J omega Ci is cancelled. Therefore, that is equal to J omega Ci RIF V in let FL is equal to FL is equal to 1 by here omega is replaced with omega is replaced with 2 pi f R naught plus RIF J 2 pi f Ci plus 1. That is equal to let FL is equal to FL is equal to 1 by 2 pi Ci R naught plus RIF. That is equal to J one. In is VA. V naught is equal to minus RF by R1 into VA. Here VA is there. Here VA. VA is here. VA is equal to apply to that voltage. Apply to that non-inverting terminal of that op amp. Therefore, V naught is equal to minus RF by R1 into V in. V in is nothing but VA. Therefore, minus RF by R1. This is VA. VA is equal to J 2 pi f Ci RIF into V in J into F by FL plus V naught by V in is equal to minus RF by R1 into J 2 pi f Ci RIF by 1 plus J into F by F. This is the lower cutoff frequency. The bandwidth is equal to FL minus FH. FL minus FH. FL is depends on FL value is depends on coupling capacitor value Ci. FH is depends on gain of the top. This is the bandwidth of the amplifier. This is the gain with feedback, that is A. With feedback, that is A. AF is equal to minus RF by R1, J2 pi f CI, RAF 1 plus J, F by FL. FL depends on coupling capacitor, CA. Coupling capacitor. FH depends on the closed loop gain of the output, that is A. Closed loop gain of the output. And by